What if I told you there was an invisible force field that surrounds our planet and protects us from the deadly radiation of space? No, it's not sci-fi, it's real science. Today, we're diving into the Van Allen radiation belt, Earth's very own cosmic defense shield. Imagine Earth as a superhero, and like any superhero, it has a suit of armor. That armor? The Van Allen radiation belt. So what is it exactly? It's a pair of donut-shaped zones made up of high-energy charged particles, mainly electrons and protons, that are trapped by Earth's magnetic field. There are two main belts: the inner belt, which stretches from about 600 to 6,000 miles above Earth, and the outer belt, which extends from about 8,000 to 37,000 miles out. These belts are constantly shifting, growing, and shrinking depending on solar activity, and they play a major role in shielding us from harmful space radiation. But how did all those particles get trapped there? It all starts with the sun, a gigantic nuclear engine constantly blasting out streams of energetic particles, called the solar wind. When these particles hit Earth's magnetic field, most of them get deflected, but some get funneled toward the poles or become trapped in loops along the field lines, like marbles stuck on a magnetic roller coaster. The result? The Van Allen belts, packed with high-speed particles zipping around Earth at near light speeds. If it weren't for these belts and our magnetic field, we'd be exposed to radiation levels deadly to life as we know it. So next time you look up, just know space is trying to kill you, and Earth's got your back. The belts were discovered in 1958 by American physicist James Van Allen during the flight of the Explorer 1 satellite, the first US satellite in space. That's why they bear his name. Since then, many space missions have studied them, like NASA's Van Allen probes, which orbited the belts from 2012 to 2019, giving us new insights into how they change, how particles get energized, and how space weather affects satellites and astronauts. Speaking of which, astronauts do pass through the belts on their way to the moon or beyond. But don't worry, spacecraft move fast enough that they pass through the most intense parts in just a few hours, limiting exposure. So why should you care about some invisible belts in space? Well, besides protecting life on Earth, the Van Allen belts can also disrupt satellites, damage electronics, and even pose a threat to space travelers. Understanding them helps engineers design radiation-hardened spacecraft and plan safe space missions. Plus, studying the belts helps us learn about space weather, which can affect things like GPS, communication systems, and power grids right here on Earth. So the next time someone asks you what's protecting Earth from cosmic radiation, tell them it's not just the atmosphere. It's the invisible, powerful Van Allen radiation belts. Thanks for watching. If you enjoyed this, don't forget to like, subscribe, and hit that bell for more awesome space science videos. See you in orbit.